I'm going to control this. Okay. So thank you very much for having me. I'm so glad to be here. Who hates writing tests? Oh wow. Okay. Yeah. Good. Because like, if all of you are like, I love writing tests, then I would be like, bye. See you next year or something like that. But yeah, like I'm telling you, this tool that is called Hypothesis is it's a Python library that basically can help you to write tests like with. So I hope that you can change your mind about writing tests, that you don't hate it anymore. But for the slides, you can actually get it online. It's posted online. So if you want to like kind of look at it afterward, you can also get it. Also, that's my social media kind of contact thing. So feel free to tag me. I love people tag me, so you can take pictures and tag me. Or ask me questions, whatever. So for those of you who hate writing tests, so what is the most difficult part of writing tests? Or even if you love writing tests, like what is the most challenging part of writing tests? Any ideas here? Silence?
Making the first one run.
Making the first guess.
Maybe get access to the inside of the function that is to be tested?
Yeah, mocking. Mocking is another topic, but I've listed 3 things. So first of all, importing the code. Sometimes, like sometimes the code, like the path is a bit funky, and like when you try to import it, it's like there's no such thing. It's like no, it's my code, but like and then just like PyTest just doesn't find it. So I hate that. Also like organizing the test. Sometimes like you write a lot of test function because you want to push the code coverage to 100% is ideal, but like above 80, let's say. You will have tons of tests if you have a big library, and then they got messy. They got like everywhere. You don't know where is where, and like you write too many tests, you spend too many hours writing tests. And the last thing is to think of the test case, because sometimes you think that, oh, I got everything covered. No, you're not. So you're missing something that actually is that little thing that you miss caused an error, and then the user may discover it. So, not good. Have you done your QA properly? So, I hope Hypothesis can help you in the last 2 cases that, you can write tests with more, like you don't have to write a lot of tests because Hypothesis can generate tests for you. And also, you can like, because Hypothesis also generates test case for you, which I would dive into more details in a bit. So, but before that, I'm Cheuk. Hello, I work for Anaconda. So I'm a developer advocate at Anaconda. I'm just running around town to tell people about like all this cool stuff about open source, like help data scientists to have better tools in their pocket. Also, I involved in some open source project in the past. I also love organizing events, so I will tell you the pajamas, so some of you see the stickers lying around. So I'll tell you a little bit about that conference later. Also, I still keep some sticker to myself, so if you talk to me about pajamas, I'll give you a sticker if you didn't get it earlier. Also, I've been doing some like kind of, Twitch thing during the pandemic because I was too bored, but I'm not doing it now. I'm here with you, So, how many of you have heard of this kind of idea that's called property-based testing? No? Yes? No? Some? I can see some. So, what is that? Like, why does it like make a difference? Why am I here telling you like about this thing? So, what makes property-based testing different from what we kind of normally do testing is that property-based testing, just like the name suggests, we just need to tell your program, or your test, what property your variables are. You don't have to provide an example, which is we normally do when we write tests. We have to think of some test case and give you some example to see if it passed or failed. So, what are the difference? Because I think for me, at least, property-based testing is that the given is very obvious. For some variables, you just this is supposed to be an integer. This is supposed to be a string. It's like quite straightforward. You don't have to think too hard about it. If you have done typing in your code, you don't have to think about it at all. It's written there. So it's very, very straightforward. But if you test by example, you have to think of okay, so I want to test all the integers. Do I test 0? Do I test the negative? Do I test the positive? Do I, is Boolean an integer? You have all these kind of things in your head. And so it's kind of more tedious. Also, like I mentioned before, if you already have typing in your code, it's effortless. You don't have to think about what type the thing is. It's written there. I mean, like, you know. But like by example, you have to like what I said. Like you have to think about like what example you can provide for that type of variables. So it just makes everything very, very simple. And also with hypothesis, it will find the edge case for you, because I can tell you a little bit about how it works in a bit. Like, because hypothesis will base on what the property of that variable is and use a strategy to find all the cases for you. So edge case can be like automatically found. Sometimes you're surprised that like some function you think, oh, I've got it all covered, but it's not. Like you find some edge cases. But if you test by example, if you forgot to put down the edge case, then you will miss something, and then your user will find the bug. So, so that's really good idea, and how hypothesis can help you with that. If you look at the example in their website, in the documentation, you will see that hypothesis, first of all, they will have some decorators. The most common one is for given. So it acts as an entry point to modify the test, because you put a decorator at your test function, it will modify your test function and become a more powerful test function. So given is one of the things that, like, later when you see the examples, you'll see like how it has it can be used. And then you will have strategies. So strategies are like things that hypothesis provide to find the cases for you for generating the test data. For example, like if you have integer, then maybe I'm just saying it here. I'm not sure. I haven't checked the source code. But for example, integer, the strategy you can be like, oh, I want to test all the positive, not all of them, but like maybe positive integer, a few of them, and then a very large one, and then a negative one, a very negative one, and 0. So you can even provide your custom strategy, but hypothesis already have some standard kind of strategy for most common type for you. Unless you have something very special, you don't have to worry about that. But also you can also provide a custom strategy, or you can provide some like customization to the decorators and the strategy together to make it like work for your case. So this is the one-on-one example. You can find it on the documentation. So this is just a function that's doing some encoding thing, right? And then come with it is there's a decoding function. So it's just a pair function, very standard. You can see this quite commonly, like among different codes. So how do we test this? So in your test code, you so the most basic thing is that you need two things, right? You need the decorator. The decorator is given here, so you see it has been used later. And then the next thing you need is strategy, because you have some text that you would be encoding, right? So it's a text. So among all the strategies, then you found that, oh, actually the text strategy may work for my code. So you import those, and then you just use it there. So like I said, the given is a decorator, so you use it on top of your test function, and then you put the text, or what strategy you're using. So you use text, and the text is oh, I forgot to highlight that, but it's like it will become the S that come into the test function. So have you ever used parameterize in PyTest? Yes. So it's kind of like that, but instead of parameterize, you have to provide all the examples. It will generate the examples for you automatically. So yeah, so you can see it's almost like parameterized, but instead of providing all the different S, it will generate that for you. So so I hope that kind of helped you a little bit. Like for example, if you are already using parameterize a lot, then instead of thinking about the cases, maybe you'll miss a few cases that you should be testing, you can just float it in hypothesis. But if you're still not convinced, you're still like, that's too complicated, I have to learn a new stuff and write tests. What if I tell you that hypothesis will write the test for you, that you don't even need to write what I've just shown? It just call a command and hypothesis will generate the test file for you. Yeah, so if you're that lazy, you can stay. But I hope you are still using typing, because if you're not using typing, this won't help you too much. So now Hypothesis has something that's called a ghostwriter. So because now typing has become more and more popular, I have a lot of people tell me that they're using typing because they want to generate the dot string automatically. So this is designed for lazy people, isn't it? So yeah, this is also designed for lazy people. So Hypothesis, as you can see from the first example I showed you before, all you have to tell Hypothesis is what type of input you're expecting. So with the typing, we can make a fairly good guess with it. So we're using the typing as a hint. So most typing case is quite straightforward unless you have something very crazy like union of things that like that we are still like sanding out the edges. But I mean most of the time there's a lot of work putting into like working with different typings. And then, the ghostwriter will go there and pick the right strategy for your input parameters and put it in the code that it generates for you. I want to show you today, but I'm afraid I can't. But like, I would direct you to like where you can try it out yourself. But what's even better about it is that they come with a CLI tool, so you don't even need to like call the ghostwriter in your code. You don't need to write any code. You just type a command, and a test file is generated. Also, bonus, if you already have black in your environment, and we use black to make the code looks very nice, as if it's already like, you can just put it on GitHub for your like testing pipeline, and voila. So it's nice. So there are a few ghostwriters, we call them ghostwriters. It's just basically a different strategy of like how to test the function. So all the details are there, so it's all like in the links and stuff. If you want to mess around, like play with the ghostwriter, that's also where you can find all the details about it. You can install it and play around with yourself to see if that's something that you would like to use in the future. So the first ghostwriter that is quite commonly used is the first one. So it just tests the function, but most of the time function won't always pass, right? You would probably raise some exception and stuff. So you can also put in what error is expecting as well. So that is just an example, the RE, the compile in RE to test it. Another strategy is, this is quite specific. Now we go to like more specific categories, like how do you indefinite? I didn't name it. I don't know how to go. But basically what it means is that like if you have a function, if you call it twice, it should be equivalent for calling it once. Now let me rephrase it. Like if you call the function multiple times, it should be equivalent of calling it once. For example, like sorting functions. If you sort it once, it's already sorted. If you call it like multiple times, it should be the same, right? It should already be sorted. So this is very useful for testing a sort function to test whether you achieve something that is the goal. Then even if you do it multiple times, it still stays there. Another thing very commonly used is round trip. So the example here is using JSON DOM, JSON modes. But like the example we had before, the encoding and decoding, that's supposed to, it's supposed to be test round trip as well, because you encode it and then you decode it, so it should come back as the same thing. So there's a lot of function that works this way, or to and from, to dictionary, from dictionary, those kind of things. It should be round trip. Equivalent will be useful if you have two functions. This is the example that I made up, and obviously, and I forgot to change the round trip. Typo, okay, I will fix it at home. Yeah, because this is the first time I'm giving you talk, so all the slides are still. But anyway, so I made up, so I'm supposed to test this equivalent with the myPal, with the math.pal. But this was supposed to be like giving me the error because what a negative y, so that won't work. But then with this, you can test like, whether something that you write actually works. For example, you invented a method that is faster than some method that Python provides. So you know that the method that Python provides is correct, but you try to attempt to do something faster, then you can compare the two to make sure that it works. So those are the more common ones that we try to cover, like all the different functions. But there's also the other things that also cover more kind of niche functions. For example, binary operation. If you have created a custom binary operator, you can use that to test things. There's also, if you use NumPy, there's also the U-fun. That's for the array U-fun. But who would write array U-fun? I don't know. So these are more niche things. But you can, again, all the details are in the documentation. So you can have a look, or you can join the workshop on the 26th of October. Then you would. So today is just a preview of what it is.
Introduction.
Yeah. So the CLI tool. So this is in your command line. So you type hypothesis, right, and then the module that you want to test. So you don't even need to provide a function. You just provide a module. You can also provide functions, but the most laziest way is to just test the whole module. So you just type hypothesis, right, and then the name of your module, and it will just, if you've done nothing, I'm supposed to give you a demo, but I can't do it now. So what you're supposed to do is to use this, and then if you do nothing, just let's say I write hypothesis, write code, then you just test the code module, and then it will just print out at your standard out. So if you look at it and say, oh, I actually want to save it, and that is my test file, so you can just pipe it into a file, then voila, that's your test file. You don't even need to open your text editor. You just type a command and you've got all the tests done. That's really nice, but why is it not so popular? I keep thinking why it's so good. Why not everybody's using it? For example, Black. Everybody's using Black now because it's so convenient and we are all so lazy. But I think there's a few catches for hypothesis. First of all, tests can run a little bit slower if you have used it extensively and if you have very complicated stuff. For example, I've talked with the scikit-learn team and they said that they don't use hypothesis extensively. They are now trying to use it for something, but they don't use it extensively because it can be very, very slow, because it actually, we skip a step, right? We don't have to provide example, but then hypothesis need to do all the tests, do all the steps for you to generate the test case. So if you have really complex stuff, for example, you have a type that is a union of a lot of different things, then this may be very, very slow. Also, the test can be a little bit harder to understand. Sometimes, it's straightforward to provide the property of the variable, but sometimes you would rather prefer to look at the example so you can see that, okay, I have these things that I have tested and things like that. So it's a little bit more hidden. You don't know what example has been generated. Some people don't like it. And also, for the ghostwriter, it's amazing. But if you haven't put down a lot of type hinting, then it's not going to be very helpful. I wish I could show you, if I show you the demo of the encoding and decoding at the beginning, everything would be nothing. It's basically doing nothing. It's not very helpful if you don't provide a type. So if you are very, very lazy and you don't even type your code, then it's not going to help you a lot. So that's the end of hypothesis. And before I go, I want to tell you about PyJamasConf, and the CFP is now open. So it won't open for very, very long. So it's on the 26th and the 24th of November. Basically, what we'll have is a 24-hour live stream. We will be non-stop in our pajamas, sitting in our living room or in our bed and watching talks and stuff. So that'll be fun. Also, if you have never given a talk and you feel giving a talk is very scary in person, then you can try giving a talk online. It's less scary. So